Good morning. You have successfully dialed into the Snowflake webinar with Devon Energy, from many pools to one modern data lake. We will begin in just a minute. Good morning. Thank you for joining today's Snowflake webinar, From Many Pools to One Modern Data Lake with Devon Energy, a Fortune 500 company. Devon is a leading independent oil and natural gas exploration and production company focused onshore in the United States. Today, I am joined by Larry Querbach, Enterprise Data Architect at Devon Energy. Larry will be our main speaker today, providing background on both Devon and their journey to Snowflake. But before we get started, my name is Mike Klaczynski. I'm a Product Marketing Director at Snowflake, and I will be today's moderator. I will follow up Larry's session with a brief introduction to Snowflake and how our cloud data warehouse is an excellent complement to a data lake strategy. This webinar will last about 60 minutes, with the last 10 minutes for questions. As we go along, add your questions to the Q&A box on the side of your screen, and at the end, we will try and address as many as we can. And a recording of this webinar will be made available shortly after we conclude today. I've had the pleasure of getting to know Larry a bit better over the last few months, as well as the challenges he and his team have been able to solve by consolidating and simplifying their data warehouse and data lakes onto Snowflake on Azure. Probably the best indicator of that successful consolidation is the fact that Snowflake now services over 4 million monthly queries from Devon users. From their Power BI analytics tools, the native OData connector, data science in Databricks, Excel, and even through direct queries in Snowflake. I'm excited to have Larry here today to share his story with you all.
Thank you, Mike. I want to thank also all of you who have dialed in. What I'm going to talk about today is the journey that Devon went on, going through 3 different attempts at gathering all of our data together and presenting it in a logical and rational way to our users. So I'll go through the 3 methods we tried, and then I'll talk about what we're doing with our modern data lake and why we're on Snowflake. So our first attempt to create an enterprise data warehouse, we used HANA. And those of you who have worked with HANA may understand some of the limitations that we faced. HANA is a memory-only system, and some of the limitations we ran into is that HANA was not scalable for us because we had too much data or too much query. So basically what we had is from our source systems, we would land our data into a landing database, and then we would do a lot of transformation to get that data into a data warehouse, and then we would serve that to our BI analytics tools. But the problems we had, it was very slow to modify because we had so many layers in the stack. It took a lot of time to do that. Also, it took IT to do all of that work. And as I mentioned, the HANA database is limited in size and scalability, and that's based on how much you buy. And we found out that after just 6 months, we had filled our capacity and really needed to have a larger box. So truly not very scalable. So what we did is we limited our data sets, so it became quite a challenge to actually get more data into HANA because we had reached our capacity. And at the same time, we were also limiting access to the data. So end users had difficulty getting to the data, as well as we had problems getting the data available to them. And all of that together, it was expensive to maintain, expensive to build and expensive to maintain, and it was slow to change. So our second attempt is what we called data services. So this was our curated data, our enterprise data. Again, we started our source systems, and we used Informatica with this attempt. So we would use Informatica data quality tool to do our transformation, and we would store that data in an Informatica database. And again, we are presenting that data to our BI and analytics tools. And in this case, the two methods of access we chose were ODBC, JDBC Direct Connect, or OData. So we put together an OData layer that would present this data easily to our users. So what we found is we became a victim of our own success. Again, like HANA, the Informatica stack that we had was not very scalable, and we found that the data services were so popular that we were struggling day to day to keep the system up and running. And the stack was a very deep stack, and there were really too many points of failure in the stack. And again, we're back to developers and change control in IT to make changes slow to change. Again, expensive to build and maintain, slow to change, and we also encountered slow processing. We got to the point where it was difficult to get our overnight processing done overnight. And again, like in the HANA situation, we had too many users. We were too successful. We had too many users wanting to use the data. So we continually fought the battle between using CPU to process data or using CPU to serve that data to the users. In our third attempt, we had an on-premise Hadoop stack. Again, starting with the source systems, we used Datamere. Now, this was really for what we call our citizen developers. This was not IT usage. So our citizen developers used Datamere, stored that data in Hadoop. The problem is that Hadoop is very challenging to get data out of. And so what they ended up doing is doing that transformation, storing it in Hadoop, and then porting it back out to a SQL Server database, again, to serve the BI analytics tools. So problems with this situation. Very difficult to support. The stack, again, we ran into limitations on the stack, ran into limitations on the SQL Server in terms of size and capacity and ability to serve connections. And from an IT perspective, we really didn't have any visibility into what our users were doing in Datamere, and that was really challenging for us because, as all of you in IT know, when something breaks, whether IT owns it and built it, IT is responsible for getting it back up. Also, because of there was really not a lot of visibility about what was going on, we had a lot of end users really duplicating the same code and lots of duplication of effort. So it was not a very robust situation. And also, the solution is really proprietary. Because it's the end users have created it. Again, IT has really no visibility into what's going on. So with all of these attempts and really not having a success, we began our search to look for a more modern platform. And so we decided that we needed to be in the cloud for expandability, and we started looking for tools, and what we decided to call our platform is the Data Hub. So let me tell you a little bit about what the Devon Data Hub is. So in our Data Hub, it's neither just a data lake nor a data warehouse. We actually are using Snowflake to serve both of those needs. So in our Data Hub, we have structured and semi-structured data, which we're storing in Snowflake. We have unstructured data, which we're storing in Azure Blob. But I'm going to focus on the structured and semi-structured because, hey, this is a Snowflake webinar. So basically, the process of what we're doing is we're bringing our raw data in from our source systems without transformation. So for our end users who are already wanting to get that data and getting logins to all of our systems, those of you who support databases understand that your users need that raw data because you haven't created the warehouse presentation for them yet, so they need to get to the raw data. They need to move quickly, and so they end up logging into multiple systems, and we have databases in SQL Server, Oracle, Informatica, HANA. So we find them really struggling to pull all that data together. So what we've done is we've brought all that raw data into Snowflake, one place. We're not changing anything in that section of the Snowflake implementation in our data lake. the data is all in one place, and because that data is all there and that data is all accessible, what our users were doing in Access or Excel or Power BI, trying to extract a lot of data and then join it together in another tool, natively simply using SQL, they can join anything to anything. As long as there's a valid join pattern, they can do that in Snowflake. In addition to the raw data, we have our transformed curated data, which comes from our data warehouse, comes from our data services. So we bring that also within the Data Hub, because one of the things that our users want to be able to do is they want to be able to join that curated data to some raw data, because the creation of curated data is a lengthy process. And so if they need to add some data quickly to answer a business question today, they can pull that curated data and supplement it with other data from the systems that they understand. So having all the data in one place is key to our Data Hub strategy. So in our transformed data, we really have two levels of data. We have what we call our enterprise data. This is IT created, IT owned, robust data governance. We also have our community, which is where our citizen developers can go in and develop the data and create data from the source data and present that data to the enterprise, knowing their own data. So IT is really not terribly involved in this. This is where we tell our citizen developers, you know your data, we trust you to know your data, and we have some minimal governance that really is governance of the platform. We have some rules around appropriate sources of data, and we control security so that we don't have people writing data to the wrong place. That's really all of our governance, because what we discovered with our Datamere strategy is we had the idea with Datamere was that our users would create things in Datamere, and then they would come to us and say, hey, make this a production data service. And what we found is that we never had to do that. They never asked us to. So what we're really trying to do in the Data Hub now is to create a very low barrier to entry, let our citizen developers create their data, and simply put enough governance around the platform to ensure the health of the platform. So the end result of this is all of our data is in one place, and our users can join anything to anything, enterprise data to the source system data to the data that is created by community users. My apologies, this is a very busy slide. So let me talk through this from left to right. So this is what our implementation is in Snowflake. This is how we put this together. Again, starting from the source systems, we're using Attunity Replicate to load data into Snowflake. And with Attunity, we're doing a couple of different things. We're doing, where possible, change data capture. So our data is at most 5 to 10 minutes delayed from the source systems, which is really important in certain cases for our users, particularly in our production data, things that are moving quickly. It's important for that data to be up to date. In cases where it's not reasonable to do CDC, particularly with things that change, where a system may recreate an entire table at night, we are batch loading those. So using Attunity to get that data into Snowflake, that's our data lake. And then from there, what we're doing is using Databricks as our transformation engine, so that we are reading the data from Snowflake, doing the transformation, and writing that data back to Snowflake. And Databricks is our tool for both IT and for our citizen developers. And from Snowflake, continuing on to the right, we're serving that data, again, to that OData layer, which has been very popular with our users. It's very easy to use in Excel. Also Power BI, and additionally ODBC and JDBC. So what else have I got going on this slide? So one of the things I think that's really critical with Snowflake, and what really makes this possible for us and allows us to serve all of our users' need, is the separation of storage and compute. In our previous scenarios in Informatica, in HANA, storage and compute were fighting for the same resources, the same memory, the same disk, the same processing. In this case, in the case of Snowflake, we store the data, and then we can have as many compute engines as we need, all using the same data, rather than having to have multiple copies where we tie data and compute together. We simply have one copy of the data, and we can create as many compute engines. And what we have illustrated here is, for example, at Tunity, we have a medium-sized warehouse. Databricks is extra large, because there's a lot going on there. The OData and Power BI are both large. And actually, to tell you the truth, I think we've changed the size of those, but that's also a really beneficial thing with Snowflake, is that we're able to dynamically change the size of the warehouse to meet the need, and also to help us control our cost. So, basic features of our implementation, again, we've centralized all of our data in a single place. We've simplified our data transformation, and we've made data transformation accessible to our users. Now, I'm not going to tell you that Databricks is simple or that Python is simple, but it's straightforward. Once you learn the basics of the language, it's straightforward to write your transformations, as opposed to using a tool like Informatica, which is pretty complicated, or creating transformations in HANA, again, pretty complicated. So I think really what we're doing is we're democratizing that transformation to where our end users have the ability to learn the tool set and to actually do what they need to do. Also, our existing tools, the end user tools, work just fine with Snowflake, and so there's really no change other than for our users, for example, Power BI. They need to change their source from wherever they were previously to Snowflake, but they don't have to change anything but the data source, and that's a simple change most of the time. Really, really important is scaling for the workload. Again, in our previous scenarios, we became bound by the architecture, bound by how much we had purchased. And as you all know, in the cloud, you can eat as much as you're willing to buy. And so we have the warehouses set up to where they will scale up and scale down to meet the demand. And that does several things for us. It allows us to meet the needs of our business as well as control cost better, because we're not buying the big box and trying to estimate our load and buying the big box and then finding out 6 months or a year later we didn't buy a big enough box. We simply scale up or down, which is really helping us, as I said, control our costs. And we're finally in the scenario where we can load all the data, which we've never been able to do in any of our previous tries, because, again, we get to the situation where data and processing are fighting for the same resources. But being in the cloud, being in Snowflake, we simply scale. Let me talk about a little more details about the Data Hub. So Tunity, I mentioned, we're doing near real-time replication, change data capture from our structured database where it's possible, and batch where it's not. This is an IT tool only. So IT owns this, IT manages this, and we have proactively gone through all of our source systems and began to replicate those. Now, a caution here, something that we learned, we got ahead of ourselves, and we replicated some data that we probably shouldn't have without asking. So one of the things I'll say to you is, as you begin to load your data into your data lake, don't get ahead of yourself. Make sure that you're in touch with your data owners and make sure that it's okay for you to replicate that data. Lessons learned. So let's talk about Databricks a little bit. One of the things that's really nice about it is it's a first-party Azure service, and so it simply goes on our Azure bill. It's very easy to use, very easy to scale up and down. It helps us decouple that transformation and storage, because Snowflake gives you the compute engine, but you still have to do the computation. So using Databricks clusters and Snowflake Warehouse allows us to separate that transformation. Databricks seamlessly integrates with Snowflake, and it's, as I said previously, it's for all of our developers, both IT and citizen. And additionally, I haven't mentioned this yet, but also our artificial intelligence and our machine learning. Our data scientists are pretty happy with Databricks and really happy with Snowflake, because they finally have a platform where they can play with lots and lots of data at scale and at reasonable speeds. And again, the Snowflake, we have taken the strategy with our Data Hub that we are going to open all of the data to everyone in the enterprise. If you have a badge and you can get in the door, you can see all of the data unless there's a specific reason that we have to secure it. PII data, our business development data, things that we don't want the general public to know, but I would say 95+% of our data is available to all of our users, which in the past, our strategy was to have people ask for everything they wanted. So we've really turned that on its head, and we're saying the data's there if it helps you do your job, if it helps you answer business questions, go for it. So let me talk a little bit about the environments that we have. We have a temp database, which is ad hoc development. Things don't stay around there. Anyone can do anything in there, so it's not a place to do things that have permanence. And we're also deleting things after 90 days to kind of keep that database from becoming just a mess. Our dev database is for teamwork development, and this is our citizen developers and our small teams. And then we have multiple production databases. So we have databases for our enterprise data. We have several databases, and within those enterprise teams, they each have a dev stage and production, and we're following a full SDLC. The community database is a little different because, again, we're trying to lower the barriers to entry. So for our community, because our community doesn't really care about staging, we're simply going dev to production, again, with some controls around code migration and appropriate security and appropriate sources. So why is this important to us? What has this really solved for us? So I think one of the biggest ones is access to all of the data. Not only access to all of the data without having to ask permission, but access to all the data in one place. Again, join anything to anything. And that's something that we've never had the opportunity to do before. We've always had to extract data from various systems and use some transformation tool, HANA, Informatica. Our citizen developers use Datameer, some of them use Access, some of them use Excel. So having all of that data in a single place where you can write a query or you can create a Databricks job and have all that data there is key, I think, to the success of the Data Hub. Truly being cloud native, I think that's important because of the scalability and the cost control that you can get in the cloud, and just really being able to do everything that you need. I love this one. Do your worst. We used to have, particularly in our Informatica stack and in our HANA stack as well, we would have users write those queries, those Cartesian product queries that really can bring a system to its knees. And we would frequently, way too frequently, have to restart servers because they would lock up because we would have queries that were unmanageable. In a cloud environment, in Snowflake, the query can run and run and run, and it will return, and the only impact is cost. So we're really starting to look at our costs and understanding what our costs are so that we can reflect that back to our users and help them understand. So IT cost is becoming a little more transparent instead of simply IT spends too much, but hey, I need IT to do these things. We're starting to have the ability to say, this is what it's costing to do the things you're doing, so you can make the decision, business, is this worthwhile? Is this a cost that we should bear as a company, or do we need to think about doing things differently? And I think the last thing is the users see the data in the ways they're used to seeing it. The curated data is exactly the same. The source systems they were connecting to are replicated and look exactly the same. So it's really very much the same environment, just everything together. So I'm a data architect, and data governance is really important to me. And I really feel that this platform has allowed us to really take some giant steps forward with data governance. Now, Devon has been working on data management and data governance for about 6 or 7 years, but we had problems with really trying to get it right. One of the problems being the data was spread all over, and trying to govern thousands of SQL Server databases, which we truly do have thousands of SQL Server databases, it's really difficult to govern that. But if you say, I'm going to put all my data in one place and I'm going to report from that, it's much easier to govern because it's one system that you have to go to. We have a data governance council, and I believe that being able to have visibility in the data is truly empowering that governance council to step up and take the next step and really begin to govern the data rather than just talk about data governance. And as I mentioned previously, we're securing by exception using role-based security, which works very well in Snowflake. We're only securing the data that has to be secured. And I feel like we are gaining trust with our users, being able to have the data from the source systems available, have the curated data available, and let them see exactly what the data is. I believe that the end users are beginning to trust the data in the Data Hub much more than they did our previous solutions. And being able to maintain just one technology stack, and particularly cloud, where we're not truly maintaining it like we were with our previous solutions. I didn't mention previously, but those 3 solutions I talked about up until about 6 months ago, they were all 3 still running. We've since decommissioned the Hadoop and data mirror, but we had all those technologies and all the complexity of those stacks, and we're moving toward having simply one stack to maintain, which really helps out with administration, helps out with governance, helps out with security. So why do I care about data governance beyond being a data architect? We've been in Snowflake in production, I would say, since early this year. I would consider it to be in production. We already have more than 50,000 tables, 40 terabytes of data, and more than 1,000 users. And as Mike mentioned, we're serving over 4 million queries a month. So that's a lot of data. That's a lot of complexity. And if we're not governing the data lake, if we're not governing the data warehouse, what you really get is a data swamp. And I think that's one of the failures that a lot of people that struggle with data lakes have, is that they don't have governance, or they don't have the right kind of governance, and their data just becomes unmanageable. So what does Devon mean by data governance? We have our data is from our trusted sources. So one of the limitations on creating data that goes back into Snowflake into a trusted production environment is that we make sure that those sources of that data are trusted. So we're not going to let our developers go to the temp space or to the dev space. They need to go to a source system or to one of the production systems for that data, so that we have trusted data and we create new trusted data from that data. Also, the curated data is created with appropriate controls, and I put appropriate in quotes because it depends on who the developer community is. So appropriate controls for IT is the standard IT controls. We're doing code review, we're doing a full SDLC stack. But with our community developers, what we're doing is we're saying, we're going to govern the environment, we're going to trust you with the data. So we're not doing any code review other than very simply saying, are your sources appropriate? Are you using security correctly? Okay, we'll promote your job because we trust you to know your data. And also appropriate in quotes, role-based access control. So appropriate in our case means everyone gets access to everything unless we have to secure it. So some of the challenges that we've faced, and this is particularly with our citizen developers, is balancing control with ease of use. And we struggled with this early in the year, wanting to have control and talking about doing code reviews of community development. But if we did that, they would never develop, and we would end up with things in temp space that people would make decisions on data that probably wasn't good enough. And I'm sure that some of you have had that experience. So that's a real balance, trying to figure out for your company, what is that balance for your users? How much control does IT need? How easy can we make it for citizen developers to create data that's considered trusted by the enterprise? And do you make all of your data open to all? What is your strategy on that? Like I said, we've taken the strategy of everything's available to everyone unless we have to secure it. And I'll also say pick your battles. I learned this one over again several times this year. Make sure that what you're fighting over with data governance, don't dig your heels in too much. That's a lesson I have to keep learning. because I want data governance to be perfect, and it can't be. And so be careful and pick your battles and decide what's important, where you draw the line and say, no, we will not do that, and where you say, okay, that's fine. And that's a challenge that you just have to work out for yourself. So here's where we are on our implementation. We are ingesting raw data from all of our source systems. We started with a boil the ocean approach, quickly learned that that was not the way to do it. And so now we have a very easy path to request new tables or views to be added to Snowflake, but we're only adding data on request because some of our systems have thousands and thousands of tables, and that doesn't really make sense to expose that. We have sandbox development and production. We have the code migration tools built. We've granted open access to everyone, and we have the citizen developer migration process, which, like I said, we had some challenges trying to decide how much control we were going to exercise versus how easy we needed to make it so they would actually use it. We're in the midst of decommissioning our legacy warehouses and tools, and also working on ingesting all of our curated data. So we have two stacks of curated data. Our data services, we are bringing all of those into Snowflake. Our HANA, we're starting to work with that and really trying to determine what are the appropriate things to bring into the warehouse. And making all of those last two work is we are beginning to rebuild our curated data natively using Databricks. So our data services, which were built in Informatica, we're rebuilding in Databricks. And all of our HANA data warehouse, we just had a kickoff this morning. We're going to start rebuilding all of that curation in Databricks. The idea being eventually we will significantly reduce our footprint on Informatica, as well as no longer need the HANA warehouse. We'll still, of course, have HANA for SAP, but this is part of our cost cutting and cost savings is moving to a tool set that is overall cheaper and decommissioning some of those more expensive tools. So we had some immediate wins. First one of the things being a production company is greenhouse gas is very important. So we had a greenhouse gas regulatory report that it took us 48 hours to run. And now that we've moved the data into Snowflake, it truly is running in minutes. From SQL Server to Snowflake, it's amazing. Another example is we have subsurface applications and a production company has a tremendous amount of data when we drill. That's what we consider subsurface. We're drilling or producing. And we had a 15-hour process to prepare data that we're now down to 30 minutes. And most of that is simply loading data, loading a lot of data. And we did some testing before we decided on Snowflake. So we simulated 2,000 random queries against one of our huge tables, 40 billion records, and all of those queries returned in under 10 seconds, which is amazing when you consider what that would be like in SQL Server or Oracle. The question on the right, I think it speaks to, this was from one of our data management professionals, it speaks to us looking for a solution that would work, and they're really saying, is this where we're going to stay? And given the success that we've had, I think Snowflake's here to stay. So my closing thoughts. Again, I have probably said this a dozen times, having all of our data in one place is key to our strategy, giving our users the capability to get to any data that they need very easily. And separating the workloads, that separation of compute and storage is also critical to our success. In all of our previous attempts, we had downtime because the competing workloads would bring the server down, or we would have to bring the server down. So we struggled with uptime and reliability, and now we're in a situation where the data is just always there, assuming, of course, that Azure is running. I think it's easy. It's very easy for our users and for our developers to adopt this new platform because it looks just like everything that they're used to. It's a traditional database. It's just a traditional database that has all the data that they need, and they can get all the data in one place. Again, consistent location for the data, Doesn't matter what you're doing, what tool you're using, the data's in a consistent place. I don't have to connect to SQL Server and Oracle and HANA and Informatica. Scalability is a key as well. We had a number of queries that users couldn't actually run in the tool set, either our data services or in HANA, because the query was too large or too complex, and we didn't have the capacity in the system to actually run it. So having that scalability means that those queries that we could never do before, or we'd have to do in parts or work around some way, we can just do now. And it's comparatively low cost. I'm not going to tell you it's cheap. I'm not going to tell you it's free. But compared to buying a big box and trying to estimate how big a box you need and running that big box 24/7, whether you're using the compute or not, as opposed to scaling up and down with need. So that's all I've got to say till we get to questions. So Mike, I'll turn it back over to you.
Awesome. Larry, excellent presentation. And thanks again for sharing your story. Now for everyone, before we begin the Q&A portion of this webinar, let me take a few minutes to provide a bit of background on Snowflake. Feel free to use this time to add any questions you have for Larry in the Q&A box on the right-hand side of your screen. So a little bit about the Snowflake story. Snowflake was founded in 2012 by a team of database experts and industry veterans from Oracle, Teradata, and Cloudera. They knew the existing approach to data warehousing was antiquated and not designed to take full advantage of the cloud. And from the very beginning, Snowflake was designed specifically to leverage all the capabilities of the cloud, making us very different from everyone else in the market. Snowflake became generally available in 2012. And in just 5 short years, we became the enterprise standard at over 3,000 organizations. We've earned leadership positions in both the Forrester Wave and the Gartner MQ, and raised nearly $1 billion of funding to help accelerate our product development and provide our customers with world-class support. At the core of Snowflake's success has been our unique multi-clustered shared data architecture. Now, as Larry was saying, the storage is decoupled from the compute. And what this allows you to do is have each part scale independently based on the customer's particular needs. Snowflake allows you to store both structured and semi-structured data, including XML, JSON, Parquet, Avro, and ORC, and you get to query it all using SQL. Now, the second layer, the compute layer, is where our customers provision virtual warehouses that match the workloads that each of their teams intends to process. So each of these compute resources is isolated from the others and can be scaled up and out independently in just seconds to match the instantaneous needs of each workload. Now, for example, ETL, reporting, ad hoc analytics, and data science now never have to compete for the same resources. And what this allows you to do is have concurrency. Concurrency is now a sign of success and not a headache you need to manage. And then the final outer layer is the services layer. This is what allows us to offer Snowflake as a data warehouse as a service. Simply load your data in and begin querying, and we take care of everything else for you. There's no partitioning, indexing, adjusting distribution keys, or post-load vacuuming required. It's exactly this architecture that allows us to have such a compelling solution for both data warehouses and data lakes. So like Larry pointed out, traditional data lakes have many drawbacks, including slow performance, high complexity that's tedious to manage, and poor governance that frequently leads to obscure, messy, and inaccessible data, right? The proverbial data swamp. All these problems become even more and more untenable as more and more users and ETL processes try to access the data directly. Now, a few years ago, Gartner claimed that about 60% of big data projects fail. Well, they've recently significantly adjusted that number up to 85% failure rate. So that means roughly 1 or 2 out of every 10 big data projects, only 1 or 2 out of every 10 big data projects succeed. So whether you already have a data lake or just beginning to go down that path, Snowflake can help you mitigate that risk. So like Larry, many of our customers choose to use Snowflake as both their data warehouse and their data lake. eventually foregoing the need to manage two separate systems and all the ETL processes associated with transforming data back and forth between them. Now, because Snowflake is able to natively store both structured and semi-structured data, you can stream raw data in directly and finally be able to afford to keep it all. Now, the biggest benefit comes from the fact that the data is instantly available for data warehouse workloads. So the ad hoc analytics, the reporting, the dashboarding, and even data science. The data is already there, ready to go. So that's why Snowflake makes for a very effective data lake. But for those customers that choose to keep their data lake separate from their data warehouse, Snowflake is also a great performance booster. We recently announced the addition of materialized views on external tables, allowing you to keep your raw data in your traditional data lake of choice, yet still having the ability to query aggregated views of that data rapidly in Snowflake. With our Streams and Tasks feature, you can now keep those materialized views live and up to date. And should you choose to, you can now mirror and ingest your existing Kafka streams directly into Snowflake, or use Snowflake Snowpipe to automatically handle ingestion of data from external cloud storage blobs like S3 and Azure Data Lake Storage. So whether you choose to completely replace or augment your existing data lake, Snowflake is a great solution. So with that, let's go ahead and turn it over to questions. Again, please add your questions to the Q&A box on the right-hand side of your screen.
Okay, so Mike, am I reading these questions or are you?
I'll go ahead and pick some off of here. Feel free to pick any that you like here. Let's go ahead and take this one here from Chip. What is meant by a valid join pattern?
Very good question. So what I meant by a valid join pattern is the tables that you're trying to join have data that's joinable. That didn't make any sense. So, for example, what's key in production is the well. So if I have a well key in one system and I have the same well key in another system, then that's a valid join pattern. So anything that you could join that our users were previously joining by pulling that data out into another tool, that's what I would consider a valid join pattern.
Excellent. All right, next question comes from Mike Robertson. With so many systems integrated into Snowflake, how do you ensure users don't have access to data they shouldn't?
That was a bit of a challenge for us, and that's why we moved from a boil the ocean to on request. And we're using our Data Governance Council to help us with that. So before we bring a new system in, we talk using the Data Governance Council and that data domain owner to ensure that the data that we're bringing in is data that we can expose to all of our users. Now, we don't have a lot of PII data, and we actually have not brought any PII data into Snowflake yet. So we'll have to deal with that when we get there. But for right now, the sensitive data really is our business development data. That's been our most sensitive case. So really asking the questions and working with our customers, working with our user community has allowed us to make sure we're only showing the data that we can. So for data that isn't public, we create a separate role and a separate security group in Snowflake, and we add people to that, again, talking with the data domain owners.
Great. Next question comes from Fiona. How do you promote objects from dev to QA to prod? Do you use any tools?
Yes, we're pretty much a Microsoft shop, so we're using Azure DevOps, and some of our really smart developers wrote some hooks into Databricks where we're actually using Databricks and the Git repository behind DevOps to do our promotions. So our developers will create the Databricks notebook, and then they will issue a pull request and start the standard process of data migration, but it's all being done in Azure DevOps.
Great. Another follow-up question from Fiona. How did you extract data from SAP ERP and ECC to Snowflake?
We're using Attunity for that. And we did have some challenges initially getting things working, but things are working just great. We're using Attunity with CDC on the ECC side and on the HANA BIDW warehouse because most of that data is created overnight. We're using batch, and those are huge tables. But Attunity is our tool for that.
Okay. Next question's from Buster. How do you organize your data in Snowflake? Do you have separate database for each source system or all in one database with separate schemas?
So every source system gets a database, and the schemas that are in that database are the schemas that were in the source system. The only change that we're making with the source systems is we're naming them after the application, not after necessarily the database name, because typically the database name behind an application doesn't really tell you what it is, or it's confusing. So we name, for example, our WellView database WellView, but the schemas are exactly what our users are used to seeing. Our curated data, we have top-level databases for our data services and for our HANA data and for our community, and within that, we have established a set of data domains working with our Data Governance Council, and we have those as schemas. So when you look at the curated data, regardless of the source of curated data that you're looking at, you'll see familiar data domains, and you'll be able to find the data that you need because it's organized in the same way.
All right. Next question comes from Beamson. What functions are usually performed by DBAs and IT infrastructure department for Snowflake?
So our DBAs are mostly focused on security because we're using Attunity for most of our replication. So that replication, Attunity is creating that. So a DBA will create databases and schemas, but Attunity will create the tables. We do a lot of work with security. Let me think what else our DBAs and sysadmins are doing. It's mostly around getting the data loaded and security, particularly making sure that with our curated data that only appropriate users are allowed, or developers are allowed to write curated data.
Okay. We've had several people ask if you can share the details behind the size of the warehouse you used when you ran that test of the 2,000 concurrent queries.
I wish I could answer that question. I don't know. I'm sorry.
No worries. All right. Next question from Mike. Are end users using SQL? If so, which platform are they writing SQL on?
So we have end users that are using SQL or tools that use SQL. So we have end users that are simply logging into Snowflake and writing queries there. That's really more exploratory. We have Databricks, which IT is not using straight SQL, but our community developers are. We made a decision with IT that we were going to do everything through Python, so we're not doing actual straight SQL, but our community developers are that's what the tool they're used to. We also have end users using Power BI, which is SQL-based, and something else I can't remember. ODBC and JDBC are also, whatever the tool behind it, those are also SQL. So SQL is the predominant language we're using.
Excellent. Next question is from Faisal. What were some of the difficulties you faced getting data out of Hadoop?
Sorry, that's kind of before my time. So what I have is stories. I was not working with Hadoop directly, but my recollection is because of the way that data is stored in Hadoop, it was just more challenging. Plus, Hadoop isn't really designed for queries at scale.
Okay. Next question is from Kirill. Do you use any specific software or tools for data governance and dictionaries / business entity management?
That is actually a gap in our stack, and we're aggressively looking for a catalog because given the number of tables we have and the amount of data that we have, we've recognized that as a gap. So right now we do not have a good strategy for that. So we're working on that. But really where I want to get to is having a catalog tool that will do its own discovery and allow us also to do some crowdsourcing of quality of data. But unfortunately, we don't have that right now.
Okay. Next question. How do you manage workload across your Snowflake warehouses and thousands of users? Do you have concurrency issues and or query queuing? And the last question, what do you use for authentication in the database?
So authentication in the database, we're using SSO. As far as, I'm sorry, what's the first part of the question again?
So how do you manage all the concurrent queries? Do you see any sort of queuing, or do you have automated processes to automatically scale up and out Snowflake to manage high concurrency?
We do have our warehouses set up to scale both horizontally and vertically, and our admins keep an eye on that to make sure that we're scaling. We have several of our warehouses are really system use, like our Tunity and our Databricks. We have warehouses for simple queries. Power BI has its own warehouse. So because that warehouse can scale both horizontally with more compute engines and also become a larger compute engine, we have them set up to where we hope it's big enough, but we keep an eye on it to make sure, and if so, we bump it up to a larger size. But we're really trying to keep things as small as we can from a cost perspective, but we just keep an eye on it. But there's a lot of scalability that we have just natively.
Perfect. Next question. How long did it take to implement Snowflake, and did you need to reskill or hire new resources?
So I would say we worked with it for about a year before we went, about 6 months before we would have considered it production, and we reskilled. We have a pretty talented IT staff here, and moving from traditional database to Snowflake is simply a shift to another database. Most of our DBAs manage multiple different environments like SQL Server and Oracle, so that really wasn't as much of a challenge. I think the larger challenge was in the transformation tools, moving from Informatica and HANA into Databricks. That's a pretty significant change. So we've done a lot of internal training. We've also had some external training as well.
Perfect. Next question's from Brian. How do you encourage your citizen developers to use data from the data warehouse once it's curated and moved there and no longer pull it from the data lake?
Actually, we're okay with them pulling it from the data lake. It's really up to them. But what we don't want them to do, and we prevent them through the migration process, is to pull it from a temporary space. Like our temp database is really a playground, and so we won't allow curated data to be created from that. But as far as saying use the pre-curated data or use the raw data, we really leave that up to their experience, and because right now they're doing that anyway. They're pulling data from our curated sources and from the raw sources and using whatever tools they have to combine it. So we're not really changing the pattern. We're simply enabling the pattern to enabling the users to use their patterns in a more effective way and have a lot easier access to the data.
Excellent. And a little bit of a follow-up question here. How do your end users search and find the data they need and ensure that they can trust a particular data set that was curated by a citizen developer?
We're going to get a catalog to help us with that. That's why I said we really need to have a catalog, and one of the key features that I'm looking for is that crowdsourcing, the ability for the people that know the data to comment on the quality of the data and to give some descriptions. Right now, it's a challenge for us.
Okay. Next question from Kelly. Larry, what do you wish that Devon could have done differently from the start?
Excellent question. I wish we had laid out our governance patterns before we started, because we started loading data before we thought about how we were going to govern that data. And so we've had to back up and redo some things. We've had to take some things away that people got used to having. So I wish we really had thought more about governance going in. I think the technology stack and the work we did with the technology was simply a matter of mastering a technology. But again, I'm a data architect. Because we didn't think data governance from the beginning, I think we had some missteps, and we're still dealing with some things that really are ungoverned that we need to get under governance.
Excellent. Well, thank you everyone for attending today's webinar, and Larry, thank you so much for sharing your story and your presentation. Now, before we leave, I did want to give everybody a heads up that we will be having our Summit World Tour kicking off in September and October later this year. So if you're in one of these cities, San Francisco, Chicago, New York, London, or Sydney, please feel free to join us. And if you want more information about the Summit World Tour, that should be on the right-hand side of your screen in the resources section. So with that, thanks again, everybody. Thanks again, Larry, and we'll see everybody next time.
Thanks, everybody.